friends, now we will discuss about the Fourier transform infrared spectroscopy (Ftir) equipment. This equipment is used for calculation of the functional group, the chemical bonding in the prepared materials. So just this is the screen. We can see the spectrum of the Fourier transform infrared spectroscopy. Before explaining this Ftir spectrum, first you go on how you prepare the material and then how you put the material in the equipment, and finally you get the spectrum on the screen. Just this is the system through which you prepare the sample in pellet form. You apply some pressure and you formally prepare a sample using KBr as an ingredient materials. Suppose you can see, yes, this is the metallic oxide semiconductor materials. Just you mix the materials in a mortar pestle. This material is completely mixed with KBr. वही दिखा दीजिए. Yes, now this KBr mixed powder is being just like inserted in this devices, and you apply some mechanical pressure on this, and we found some pellet like for we obtain. Yes, this is the pellet like materials we form. This pellet is formed by using the mix the semiconductor materials with KBr, and finally you put in this devices and you apply some mechanical pressure, and finally we get. Now this sample is now being Ftir equipment. This is a Fourier transform infrared spectroscopy, and just you put the samples in this equipments, and IR radiations are being allowed from the sample, and just the spectrum of this IR radiations in this screen. You see here the x-axis is the wave number and y-axis is the percentage of transmittance of the sample. We see the various peaks on the sample. These are the percentage of transmittance peaks here, and these peaks here, and this peaks here. These peaks have, this is the vibrational frequency of a material, atoms of a materials inside the crystals. We know the IR radiations frequency are beyond the visible range. This way, on the x-axis we have a wave number, this unit is per centimeter, and this on y-axis is the percentage of transmittance of this IR radiations waves, and these peaks represent the frequency of the in per centimeters of this prepared semiconductors materials. Now we with the help of this frequency we can define the types of functional group in the material, because each atoms in a material vibrate with some frequency. So the frequency can be matched with this obtained data. Atoms in a molecules is vibrating in the some particular frequency, and this frequency can be matched with a standard data samples. Now on the basis of this result we can say this material have certain functional group, maybe the chloride of a materials, the oxides of a material, nitrate of the materials. Thus, in this way, this material is very useful to find out the important functional group the chemical bonding in the material. But what is the importance of this FTIR improvements? Generally, when any new materials we prepare, the old bonds break down and new bonds form. So what will be the new chemical bonding in the materials? And if the old bond break down, the new chemical bond nature can be obtained. First step of the sample, you prepare the samples, and the samples can be mixed with KBr, just we have seen, and then you form a palette using a hydroelectric pressure and applying magnetic force, and finally you put the sample in these devices, in these equipments, and higher radiation will allow to incident on this material, and we get a spectrum of this materials, and these spectrum define the vibrational frequency of the atoms of the molecules, and this frequency can be compared with the observed data file, and on the basis of this data we can say that these types of functional group present in the material which are vibrating in a particular frequency.